So Rickard will give us a update.
Thanks, David. Yes, so I'm Richard. Hi. Yes, so my talk is going to be about machine learning for language processing. So actually the structure of my talk is stolen from Fredrik's talk, which we had some time back. So it's going to be very similar. So I'm going to give a short introduction to the field and say how this field has changed by the introduction of, in particular, deep learning methods. I will mention a bit about what challenges the field faces, and finally, just a quick taste of the research that is going on at this university in this area. Okay, so what is natural language processing? So my practical definition would be that it's the applied science of building software tools for, well, doing something useful with textual data as input. Well, I think we are all familiar with that. I mean, there are simple things which are mundane these days, like spam filters and so on, but today there are also more impressive utilities. I think the flagship nowadays is machine translation, which has improved in the last few years so that it's almost becoming useful now. So another example of a practical application in language processing, which we have worked on at this department, is the task of summarization. So let's say that you have a bunch of documents or a long document, and you don't have the time to read it. So then the task of the software is to produce a short text that you have the time to read. So that summarizes the important content of that document or collection. And another slightly more low-level application I would like to mention is the task of semantic row labeling or information extraction. So let's say that you're building some system that is crawling business news or something like this, looking for descriptions of when companies purchase some other company or something like this, and you crawl a lot of these texts. So then we need to identify when we see such events in the text and which are the entities involved, who is doing the buying and who is doing the selling, and what is being bought and when and where and so on. So this is something that I have wasted some time working on. Yes, so let's come back again to the question of what is language processing as a field. So I said previously that this is some sort of applied science, but if it is an applied science, what is the basic science that that is drawing from? I mean, if we think of pharmacology, I mean, it draws from organic chemistry and so on. So what is the basic science that language processing draws from? And my answer would be that there is none. So many people would disagree and say that it's linguistics, but the tragedy is that linguistics does not provide anything that we can actually build a model from. So the tendency in the field has been that system performance has improved as the technologies diverge from linguistic theory. So if we trace the development of the field, so back in the 80s, language processing systems were implementations of linguistic theory, but it turned out that this was like a house built on sand. It just didn't work well when it met reality. So there's a famous quote by Fred Jelinek that says that every time I fire a linguist, my system starts to work better. And I'm not saying this to bash the field of linguistics. I think it's a real tragedy. But what happened was that the field of language processing was infected by the data virus. I mean, the vector was speech recognition, and from this field, language processing was infected by this virus, and by the mid-90s, it had taken over. So since then, the dominant technology in language processing has been based on machine learning. But this is still a development that continues. So let's see how the field has evolved in the last few years. So if we look at what NLP systems tended to look like 10 years ago, so then the typical way that these systems was structured in those days was that we built complex systems by combining subsystems in something called a pipeline, so that we started by carrying out simple tasks. So if we have some sort of document processing, we would start by extracting the words, for instance. Then we would gradually refine this analysis. We would add more and more information, so there would be subsystems that would carry out various types of linguistic analysis. So all of these, so I mean, the change compared to before that was that all of these systems were based on machine learning, but there was still a lot of linguistics inside of the system. So then after all of these intermediate stages, we would do some final analysis, and we would get the output that is the real objective of all this work. So this is something that I'm personally intimately familiar with, because I spent my years as a PhD student working on this exact task. I mean, just the last step in this pipeline, basically. So it turned out that this was all useless, because a few years after that, we stopped building systems in this way. So how do we do it nowadays? So nowadays it's more like that we try to build systems that solve the end task directly. So that instead of having all of these intermediate analysis steps, we would throw the text to some big ugly neural network, and it would spit out the end result directly. So that is so this is something that we have seen for a lot of the various problems that we work on. So it's not always that that the neural networks work much better than the previous approaches, but it's a lower amount of intermediate work that needs to be carried out. So just to make a personal reflection, so I worked on this particular problem for several years, but nowadays a master student can do the same thing. And again, it's not that the new systems work fantastically much better, but it's a faster development process. So how, if we should just summarize the field, what is it that works in language processing and what doesn't work? So if we should give a very short soundbite defining what actually works, so I would say that in a very high-level sense, what works nowadays is when we can make the task into some sort of pattern spotting problem. So I mean, okay, so this sounds very vague. So what's a pattern? Okay, in the very simplest sense, if we think of spam filtering, there are some patterns in the text that we can use to determine whether an email is spam or not. I mean, that would be just some word. So I mean, then it's extremely simple. But the recent developments in the field have made it possible to generalize what are the patterns that we can spot. So I mean, we have nowadays more general patterns. But what are the things that don't work? So the general tendency of things that don't work is that if it involves some sort of understanding of the text, some sort of reasoning, then usually it will fail spectacularly. So I think, I mean, if you have spent some time, well, translating documents with machine translation, for instance, it's completely obvious that it's. I mean, they are beautiful translations, but they are often very shallow, and they completely misunderstand what is going on in the text. So, I mean, in general, if we have a task that involves knowing what we are talking about in some particular context, then in general, it doesn't work. But the second observation that I can make is that we are sometimes surprised by the stuff that is actually possible to solve, even though old people like me don't expect it to be able to be solvable. So. What is going on? I mean, can we actually build systems that understand what is going on? I mean, does this contradict what I just said? Well, I'm not sure. So, I mean, as I said, I mean, probably it's more the fact that we can spot patterns in a more general sense. So let me take a concrete example. So recently there has been a test set published by Stanford for the task of reading comprehension. So basically the task is that we have a bunch of Wikipedia articles, and then for each article there is some sort of question, and the task of this machine is to try to answer that question by selecting a piece of the text in the Wikipedia article. So I mean, there could be some text about, let's say, the murder of John F. Kennedy, and then there would be some question, for instance, where did this happen? And the task of the system would be to say that, to highlight the mention of Dallas in the text, for instance. So, and it has turned out in the last few weeks that there are now systems that have a higher performance than human do. So that's fairly impressive. So does this mean that the systems actually understand what is going on? So I would say obviously not. So I mean, again, it's a sort of pattern matching. But to summarize how the field looks right now, so I would say that it's a type of gold rush. So I mean, just as Fredrik mentioned previously, there are low-hanging fruits being picked. So the field of language processing is a few years behind the vision field, so there are still low-hanging fruits to be picked, but they will eventually, we will run out of low-hanging fruits to pick eventually. So I mean, for the last few years there have been several academic papers of the type applying an LSTM to task X, applying a CNN to task Y. So we have been guilty of that also. But eventually, I think this will change. So I mean, science progresses in twists and turns. So now we are in a phase of expansion, but at some point there will probably be some sort of theoretical consolidation so that we develop models which are mathematically more rigorously understood. So what are the challenges that we face in the language processing field? So my answer would be that it's that these challenges are similar to what the machine learning field face. So, for instance, there's a lot of discussion in the machine learning field about explainable models. So if we have some deep neural network that carries out some sort of analysis, so why should we trust that analysis if we cannot get this model to explain what it's doing? Another challenge is reliability, and so how can we make systems that don't fail completely randomly? So is there a way to make systems that will know beforehand when they are going to fail? And a third challenge that is very well investigated in language processing, but which we don't have any good solution for, is that we have the problem of domain sensitivity. So that in general, language processing systems work quite well if the data that they are exposed to resemble the type of data that they were also trained on. So in the language processing field, there is a famous data set that was built from the Wall Street Journal, for instance. So this will mean that the systems will work well if they are exposed to news, in particular business news, but they will work much less well when they are exposed to let's say, the social media. So I mean, this is an extremely well-studied problem, but we don't have good solutions. I mean, we have incremental solutions, but we don't have really good solutions. So to conclude, I would just like to give you a very brief taste of what is going on in the Department of Computer Science at Chalmers and GU. And first of all, I would like to give I would like to advertise the event that will happen next week when our PhD student Olof Mogren will defend his thesis. So that's next Friday in the morning, and this is how he will feel after surviving these 5 years. So what does he do when he doesn't run? So Olof made some pioneering contributions to this application that I mentioned previously to summarize documents. So he was the first to show that neural word representations actually improve summaries. So a quick overview of some other NLP research going on at our department. So we have, we have some people working on a problem which is very similar to the previous talk. How can we build models that automatically learn to develop a language from talking to each other? So our student Mikael has been working on this. So me and my PhD student Louise, we have been working on how to use linguistic resources such as ontologies and lexicons. How can we plug them into machine learning so that we can get as a sort of supervision for machine learning, so that we can get better representations. And another big group at the department works on trying to develop reliable language processing systems. And in connection to the problems that I mentioned previously, how can we know when systems are going to fail? So that concludes my talk. I'm just 1 minute over time. Thanks for your attention.
Questions?
Hi.
Hi, thanks for the very nice talk. So bringing, for example, the example of Squad, we have models that now achieve test error 90 something percent. Who is to be blamed here? I mean, should we blame deep learning for achieving 92%, or should we blame the efforts for creating data sets that allow any model to achieve 92%? I mean, this is just to say, should we think about how do we actually create data sets? And I mean, the models are going to pick up whatever we'll tell them to pick up, right?
So,
do you have any thoughts on that?
I'm not sure I completely get your question, but I think, I mean, the models are probably going to improve over, I mean, they just passed this threshold a few weeks back, so I suppose they are going to improve even more. But what is your actual question?
If we want to see advances, should we start thinking about different way, I mean, maybe even different challenges? So different, I mean, you mentioned, for example, the domain effect, but this is not a thing yet. I mean, people don't really see it as a standard thing to do.
Okay, I'm not sure I completely answer your question, but I think the squad isn't actually useful for anything. I mean, it's just a look, man, no hands. So I mean, they have built a model to show, oh, we have this model that can understand text, but well, it doesn't have much of a practical value at this point. I mean, maybe it could be kind of repurposed for some practical value. So I don't have a good answer. I mean, I just have a boring answer. I mean, that's that we. I mean, we have some really classical tasks and where we are far from human performance. So I mean, so I discussed summarization, for instance, and I think we are very far from human performance in summarization. So I mean, what we have seen in the last few years is that the problem has been simplified, that people work on actually simpler problems than they used to work on. Because, I mean, now we want, or the community seems to be more interested in abstractive summarization, so that we use a neural network that generates the text instead of the simpler models that just pick sentences from the text. So I mean, the models in that area are more small scale nowadays. So I mean, the kind of boring and obvious answer is that we should try to focus on stuff that is actually useful. So yes.
Okay, let's thank Rikard.